In this presentation, we'll be analyzing the synapses of chromosomes during meiosis. We'll also be determining if the gametes produced during crossovers will be viable or non-viable. In individual 1, one of the chromosomes is MLI.JKHG and the other is GHI.JKLM. Remember that the dot represents the centromere. Let's use roller coasters as examples. We have the cars seated at each allele. The top chromosome is non-inverted, while the bottom chromosome is inverted. It's an inversion because we have to line up each allele in order for a crossover to occur. This individual has a pericentric inversion because the centromere has to be relocated. Let's say there's a crossover between J and K. The segment between cars J and K will break, reassemble, and the two tracks will randomly merge into each other. As a result of the crossover, 4 gametes will be produced. Although the crossover does occur, some gametes will be non-viable, meaning that they won't be able to survive and will die eventually. In individual 1, the first and third gametes are viable because there is no repetition of alleles, nor are there any deletions or duplications. The second and fourth allele are non-viable because both gametes were recombinants, so they had duplications which caused them to have low survival rates. In individual 2, the chromosomes are MLI.JKHG and GHKJ.ILM. If we flip chromosome 2, we get the same exact copy of chromosome 1. This means that this individual will not have any inversions or aberrations. If there's a crossover between cars J and K, there will still be 4 gametes produced. This time, however, since there was no inversion, each gamete will be the same exact copy of the parent chromosome, and all the gametes will be viable because there was no recombination. We can also conclude that individual 2 is more fit or is more likely to survive for a longer time than individual 1 because all its gametes were viable. They're also able to reproduce healthy offspring and pass on their genes to upcoming generations.